In this example, we're given this function, and we want to evaluate what this expression is, f of x plus h minus f of x over h, and then fully simplify. If you're wondering why we care, we're going to see in the next couple of weeks why this expression is so important. It's going to be a key part of our definition of the derivative. So for now, we're just going to practice how to actually evaluate it. So put this on pause for a second, see if you can evaluate this expression based on the function given here, and then we'll check your answer. Okay, first, let's look at the first term in the numerator. So notice, f of x plus h. What does that mean? We go back to my function. This says, take whatever you give it as an input, square it, and add 3. So now that means I'm going to take x plus h, I'm going to square it, and I'm going to add 3. Alright, so this tells me that if I want to actually find out this whole quantity, I'm going to start with x plus h squared plus 3, and then I'm going to subtract off f of x. You need to make sure that you put all of f of x in parentheses because we're subtracting off the entire thing. So I'm subtracting off x squared plus 3, and then this whole thing is over h. Okay, so we want to simplify as much as we can, so let's do some simplification in the numerator. We're going to want to actually expand out this first term, x plus h squared. So when we expand this out, we're going to get x squared plus 2xh plus h squared. Okay, then I still have plus 3 there. And then now I'm at this, I want to distribute this minus sign to both of these terms. So I'm going to have minus x squared minus 3 all over h. Okay, so we can get some cancellation here. Notice these 3's are going to cancel, and the x squareds are going to cancel. So I'm going to be left with 2xh plus h squared over h. Okay, this is almost fully simplified, but notice I can factor out an h in the numerator. So the numerator, I'm going to have h times 2x plus h. The denominator is still just h. Now you can cancel terms like this when they're being multiplied in the numerator, or when they occur in the numerator and the denominator. So we can cancel the h's, the numerator and denominator. We're left with just 2x plus h. Okay, so that's the fully simplified answer for part A. So now looking at part B, I want you to try the same thing based on what we just did. Put it on pause, see if you can get it fully simplified. Okay, so now let's start again with this f of x plus h term in the numerator. So when I plug that into my function, I'm now going to get 1 over x plus h minus 2. Okay, now I'm going to subtract off f of x, so I'm subtracting off 1 over x minus 2. And this whole thing is over h. Okay, so here's a trick I like to use if I have a fraction in the numerator. Here's something I want you to notice. Going back to what we had up here. Notice this is the same. Dividing by h is the same as multiplying by 1 over h out front, and then leaving the f of x plus h minus the f of x right here. Right? So dividing by h is the same as multiplying by 1 over h. So we're going to use that to rewrite what I have down below. This is the same as having 1 over h times the difference of these two fractions. Now the trick is I need to simplify this, so I actually want to subtract these fractions. I need to get a common denominator. Let's look at how we get common denominators with simple fractions before we deal with these fractions that involve variables. So remember, what if I had 1/3 minus 1/4, and I want to get a common denominator? What am I going to do? I'm going to take this fraction here, I'm going to take the 1/3, and I'm going to multiply the top and the bottom by 4. Okay, that's not changing the value at all, that still reduces to 1/3. And then I'm going to take this fraction here, I'm going to multiply the top and the bottom by 3. Okay, now I have a common denominator, and we can actually subtract. You can go from there. We're going to get 4 minus 3 over 12, or just 1/12, right? That's what we learned before in elementary school. So now let's use that same idea. The only difference is that now our terms have some variables in them. Okay, I still have the 1 over h out front. So now I'm going to take this fraction, first fraction, I'm going to put this in parentheses, what I have in the denominator. Okay, I'm going to multiply the top and bottom by x minus 2 in order to get a common denominator. Alright, and then we'll look at my second fraction. Let's put the denominator in parentheses, and we're going to multiply the top and bottom now by x plus h minus 2. You got to be really careful with parentheses here. Keep everything in track. Okay, and now we can combine them. And what I recommend is you just leave your denominator in the factored form. You do not need to FOIL out that denominator. Leave it as it is. But we are going to want to simplify the numerator. Okay, so let's look at the numerator. So the first fraction I have x minus 2. Now be really careful. This negative sign that's right here, that needs to be distributed inside the parentheses. So you're going to have a minus x, a minus h, and a plus 2. What I just did in the numerator was just distribute that negative sign. Okay, now we can cancel some things. So you can see the x is going to cancel, the 2's are going to cancel, and I'm now going to get negative h. Okay, I still have the 1 over h out front, and then my denominator is x plus h minus 2 times x minus 2. Okay, we're really close. Now we notice we can we can cancel this h factor that turns out in the numerator and the denominator. So this will cancel with this, and I'll be left with negative 1 in the numerator. Let me get to a new page. And your denominator is just the same factors we had before in our denominator. Okay, and this is as simplified as we can get. So this is your final answer for part B. And that's it.